I think you all can hear my voice, right? Okay, so till now we have discussed, means in the last class we discussed theoretical continuous distribution. And if you've not understood anything, then obviously you can go to the notes or the recordings on the course web page and itself you can watch it. So we discussed about the rectangular distribution, and then we discussed about some of the examples related to the distributions of rectangular uniform distribution. Then we did some word problem, and then we moved to the normal distributions, and obviously discussed like what is the PD of normal distribution, and regarding some of the properties of normal distributions, especially the standard normal distributions when you just convert x minus mu upon sigma, and this particular thing is led to the standard normal distribution from the normal distribution. And we discussed a lot of examples using the normal distribution, and obviously we discussed some area properties of normal distribution. So these things actually help you a lot. And then we discussed the moment generating function, and at the end we discussed this particular, like how you can solve a question like this type. And obviously at the end we just also solved the questions of CMI paper. Okay, so these are the questions from CMI paper, and also we saw already how we can solve this particular question using the normal distribution. So whatever we discussed till now is good for CMI paper, but obviously there are something that has been asked there. So like us, I've seen some questions from gamma distribution or beta distribution. So let's just discuss some of the things related to the gamma distribution and beta distribution, and then we can close the probability section. So like in probability section, still there are something like basic statistics, but like basic statistics is something that cannot be taught, because something like a mean, you obviously know all the what is mean, what is a median, what is mode, all the things obviously. So what else is there to teach in the basic statistics? Obviously there will be some bar chart, like in the paper itself you can see some bar chart or some data interpretation type question. So obviously I will solve those questions for you, but obviously you need to solve those questions by understanding the chart, and by answering the questions that is given. But obviously in the probability section, in the distribution section, these are the topics from where question has been asked. And obviously the thing that has been asked here, obviously I've taught everything starting from the very basic probability till the advanced level of distributions and everything. So obviously like if you are studying about any distribution, so don't study like everything. So mainly the obviously we told you PDF, PMF, whatever that is. And apart from that, you can study the different things like mean, median, their mean, variance, and then their moment generating function, and then some doing word problem, like how you can solve word problem using those things. So we will see, eventually we'll see all those things. We have seen all those things in the section, and once we complete this part, the probability part, we will just solve some more questions also in the future. So till now you can start solving a lot of questions from the paper, and obviously you should solve a lot of questions, because I have solved some questions from you in the course, and then obviously you have to put effort from your side also. So let's just start with the gamma distribution. Like there is something called gamma integral in the mathematics. Okay, so gamma integral means this particular thing is represented by this particular symbol. So this is just like this. Okay, so gamma z means this particular gamma integral is represented by gamma z, and it means that from you have to do the integral 0 to infinity, and it has something like this: e to the power minus t to the power z minus 1 dt. Okay, so if you find anywhere some integration like this is called a gamma integral, and its means its notation is gamma z, because this particular thing is represented in terms of z. So obviously 0 to infinity e to the power minus t to the power z minus 1. So this gamma integral has some property, and based on this gamma integral, we actually do the gamma distribution. Okay, so what are the properties of the gamma integral? Simply, if anywhere you encounter the gamma distribution, simply the gamma distribution is integral 0 to infinity e to the power minus t to the power z minus 1 dt. Okay, so this is the gamma integral. Okay. The first thing is that this particular thing is noted by this symbol. Okay, gamma z. Okay, so like let's say that this particular thing is 0 to infinity. Okay, e to the power minus t and 2 to the power z. Okay, so what this particular thing will be? This thing will be gamma z plus 1. So whatever this particular thing is here, obviously you have to add plus 1, and this particular gamma will be written here. So this is called gamma integral. But obviously there are some properties of the gamma integral, and what the properties are, because this property will be enough for you to solve the questions related to the gamma distribution. So gamma n plus 1 is equal to n into gamma n. So let's say this particular gamma n plus 1, and this particular thing is n into uh, gamma n. So this particular property is there. So let's say you are talking about gamma n minus 1. So this particular thing will be n minus 1 into gamma of decrease it by 1 minus 2. n minus 2. So this thing is there, ki gamma n plus 1 is equal to n into gamma n. So this is the property of gamma integral. Obviously some other property is that gamma n is equal to n minus 1 factorial. So this property is also there, this property is also there. And obviously gamma of 1 by 2, let's say you want to find the particular any value of gamma 1 by 2. So this particular value will be uh, root pi. So these properties are there for the gamma distribution, gamma integral, and obviously this property will be useful for you solving the questions from the gamma integral or gamma distribution. Okay, so the main thing is that just remember this thing: gamma n plus 1 is equal to n into gamma n, and gamma n is equal to n minus 1 factorial. Okay, so these two property will help you solve a lot of questions. So like let's see what is the gamma distribution. So a continuous random variable. Obviously, we're talking about a random variable, continuous random variable x, which is distributed according to the probability law. So like any distribution x, if it has the following PDF, it will be termed as gamma distribution. So what is the PDF? The PDF is e to the power minus x, x to the power lambda minus 1 upon gamma lambda. Okay, so this particular properties of gamma distribution will be applicable. Let's see, we will see how it will be applicable. So first of all, the probability density function of this particular x random variable, if it's follow this particular PDF, it is called gamma distribution. And what is the PDF? E to the power minus x, x to the power lambda minus 1 upon gamma lambda, where lambda is going to be greater than 0, so lambda is positive here, and x is between 0 to infinity. And for other else any x other x point, this is defined as 0. So this particular distribution is termed as gamma distribution. Obviously like any distributions you have, obviously you can just find PDF, means obviously you can find mean, then you can find variance and MGF and all those things. But obviously, this particular thing is that if you are having any X distributions, if it's follow PDF something like this, it will be termed as gamma distribution. Okay, like let's see like what is this? How this particular thing is the gamma distribution. So like we told that I told in the beginning that if you have any probability density function fx, if you integrate it between minus infinity to infinity, you are going to get 1. Okay, so let's see this particular thing is applicable here or not. Okay, so we here just see that minus infinity to infinity, e to the power minus x, x to the power lambda minus 1 upon gamma lambda. Okay, and this should be 1. Okay, this should be 1 because this is pda. Obviously this gamma lambda is a constant in terms of x, so this thing will come out and it will be just like e to the power minus x, x to the power lambda minus 1 dx. And here you have 1 by gamma lambda, and you have 0 to infinity, because obviously this range is defined between 0 to infinity. You know that this particular integral that we have, this particular integral is the gamma integral, and value of this particular integral will be gamma lambda. So gamma lambda, so this particular thing will cancel and this will be value of 1. So obviously we are using the properties of gamma integral here, and that's why this particular distribution is termed as gamma distribution. So do you have any confusion? Hello. Yes. Is it clear now? Hello. Hello, is my voice clear now? Hello. Can you hear me now? So I was telling in gamma distributions we have probability density function something like this, and mainly the thing is that if you integrate the particular PDF from minus infinity to infinity, it is going to be the value of 1, because we know that this particular thing, any PDF we just integrate it between minus infinity to infinity, it should be 1. So now if we just integrate this particular thing, we saw that this particular gamma lambda is the constant, so it will come out, and we have just integral from 0 to infinity, the 0 to infinity, and this particular thing. So this particular thing itself is the gamma lambda. Okay, because this is, we don't know this particular thing by the property of gamma integral. Okay, and this particular thing will cancel out each other, and this will be value of 1. So overall here we are utilizing the property of gamma distribution itself. Okay, and this particular thing is termed as means gamma integral property we are utilizing, and this particular thing is termed as gamma distribution. So this particular distribution is represented by this particular, like this is the gamma, this is the parameters lambda. So this is the gamma lambda, this particular thing gamma lambda. Okay, so anywhere it is written that x follow gamma lambda, you have to understand that we are talking about a gamma distribution. Okay, so is this thing clear now? Obviously you have to keep eyes on this particular range. X is defined between 0 to infinity only, because this particular integral is defined between 0 to infinity. If it's something else, obviously you have to do some transformation or something like that. But obviously you have to just keep in mind that this particular distribution is defined between 0 to infinity. So is this thing clear, like what is the gamma distribution and what is the gamma integral? Just you have to understand the basic thing and then you can solve the question. It's not like you have to understand a lot of questions related to gamma distribution. So is this thing clear now? Okay, now at this point of time, we will just see some properties of the gamma distribution, and mainly we will see something like uh, uh, so a continuous random variable x having the following PDM is said to be gamma distribution two parameters. Obviously, sometimes like gamma distribution, sometimes gamma distributions is defined in terms of two parameters. Obviously, here that you saw earlier, it has only one parameters lambda, but sometimes it is defined in terms of two parameters, which is a comma lambda. So how this particular this gamma distribution is defined? Its definition is same. Like this particular thing is same, but just we have some constant a. So it will be a to the power lambda, a to the power minus ax, x to the power lambda minus 1 upon gamma lambda. So this particular thing is denoted as x follow gamma a comma lambda because it's a distribution in two parameters. So like if you just compare it with the above, you can see that above we have just e to the power minus x, x to the power lambda minus 1 upon gamma lambda. But here we have a to the power lambda as the additional thing, and instead of x we have ax. So if you just put a is equal to 1, if you just put a is equal to 1, then in that particular case you will get the same distributions that you have in the single parameter. So just put a is equal to 1, this particular thing will be 1, and this particular thing will be e to the power minus x. So obviously in general means it's not about a specific thing, it's in general it may happen that a particular distribution does not follow single parameter distribution. So in that case we have to you can have this particular multiple parameter means this two parameter gamma distribution also. So this is the same thing, like it's not like something else, this is the same thing. And so similarly you can just have the condition like a should be greater than equal to 0, or lambda should be greater than equal to 0, and this means a is the some positive constant, it's not like a is some negative constant, something like that. So sometimes you will find a gamma distribution in terms of single parameter, and sometimes you'll find gamma distribution in terms of two parameters also. But obviously the single parameter is the most common thing. But if you just understand this two parameter thing, everything is simple. So is this thing clear, like how the things are working for the two parameters? Okay. Now we have some properties of gamma integral, and obviously gamma integral property we saw. Obviously we have some properties of gamma distribution, and obviously we talked about the property in terms of two parameters. And when you put a is equal to 1, you get the things for the single parameter also. Okay. So let's just see some properties. And so the properties is, like if you have just if you talk about the moment generating function, then in that particular case, the moment generating function of a gamma distribution is actually it is mxt is equal to one means one minus t to the power minus lambda, and mod t less than equal to, this is the condition. So like this is the thing that need not to worry about. The thing is that just keep an eye on what is the format of this mxt. So I told them that somewhere it may be, you may be given the particular uh, you may be given some particular probability density function, or sometimes you may be given some mxt, sometimes you may be given mean and variance, and then you have to find the parameters. But obviously if you somewhere see something like that, you have to understand that we are talking about gamma distribution of single parameter. And obviously gamma distribution of two parameters, the moment ending function is 1 minus t upon a. Obviously if you just keep a is equal to 1, you get the same particular thing. So 1 minus t upon a to the power minus lambda, and t should be less than a. So these are the moment generating function for different gamma function. So obviously means like I did not find any particular questions in the book, how what are the some simple questions that I can show you on the basis of this particular thing. But obviously there is questions in the semi paper, and we will see like how we can solve a particular question. Because like there are rare questions actually people get from the gamma distribution, beta distribution. Obviously someone can, some people, some questions can be framed, but means word problem or something like that is very rare to find. Okay. So no problem, just this particular thing is there. And and then we have like some additive property of gamma distribution. So what are the additive property of gamma distribution? So it is let's say you have some n number of random variables, and those actually follow uh, gamma distribution a comma lambda I. So in that particular case, if you just want to find a distribution of summation of xi, so means x1 plus x2 plus dot dot plus xn. So if you want to find this particular distributions, in that particular case, that will also be a gamma distribution. Obviously, xi's are all the gamma distributions from the parameters a comma lambda I. So in that particular case, this summation will be also gamma distribution with the parameters a comma this whole lambda I will be summed. So this will be sigma lambda I. Okay. So this, like every distribution we talked about the additive property. So here the additive property is that the sum of independent gamma variate is also gamma variate. That means if xi's are the independent random variables, gamma random variables. Okay, and each xi follow the distribution a comma lambda I. So a is the parameters, and the lambda is the second parameter. In that case, the summation will also follow gamma distribution with parameters a. A will be the same. A will be not sum, and it will be some sigma lambda I. So means all the summation of all the lambda I. So this is the additive property of gamma distribution. So obviously, means the gamma distributions. We have the PDF, then we have the PMF, then it has the two format. The first format is about the obviously this single parameter. The second parameter are two parameters. Then we have the MGF, and then we have the additive property. And at the end, obviously, like mean and variance is there. So mean of the gamma random variable is lambda by a, and the variance of gamma random variable is lambda by a square. Obviously, if you keep a is equal to 1, then obviously mean and variance are going to be equal, which is equal to lambda. So this is the case of two parameters, and two parameters obviously put a is equal to 1, you get the mean or variance of the single parameter. Like this gamma distribution is something like Poisson distribution, because in the Poisson also we saw there was something, the format of this particular distribution was something like uh, e to the power minus x, x to the power lambda upon some into e to the power x, x to the power n upon n factorial, something like that was there. So obviously, these type of things will be there, and but gamma distribution, hardly I found any problem. So now we let's discuss the beta distribution, and then obviously beta distribution is the based on the beta integral. So there is something called beta integral also, and this is based on the beta integral. So beta distribution also has two types of distribution: the first kind distribution, second kind distribution. Because beta distribution actually have based on the beta integral. Okay, beta integral, and beta integral is of two types. So these are the mathematics concept, but obviously did not need not to worry about what are the beta integral. Just obviously it's the integral of some types, some particular format, and if you find any integral of that particular type, you can assume that this is the beta integral. So what is the beta integral? A continuous beta distribution, a continuous random variable which is distributed according to this probability law. If like any distribution which has a probability density function as this particular thing, 1 by beta mu, this is mu. Okay, this is nu, or what you can say VB. You can also study U and B. So 1 upon beta nu and mu and nu, x to the power this particular mu minus 1, and 1 minus x to the power nu minus 1. This particular thing means this particular thing should be greater than 0, and v nu also should be greater than 0, and this particular x should be between 0 to 1. Okay, this particular thing is important, 0 to 1 only, not now like the gamma distribution it was 0 to infinity, but here this particular thing is 0 to 1, and this is based on like uh, do you have any problem? I think there is some noise. So this particular thing 0 to x will be between 0 to 1. So this beta mu and nu is called a beta function, and distribution is called a beta distribution. It is represented by beta 1. Obviously, like this is the beta distribution of first kind. So it is represented by beta 1 mu comma nu. Okay, this particular thing is there. So obviously the overall thing is that this particular integral of this type is called beta integral. We just see what's the beta integral, and this particular fx is termed as the beta distribution. So like mean is obviously this particular thing you need not to remember, and this particular variance, this particular thing also need not to remember. So the main thing is that just understand that there is something called gamma and beta distributions. Obviously if questions you find something like that, just you need to be prepared that obviously we have some distribution of this kind also. There can be a lot of distribution. No, there is something called triangular distribution, or sometimes there is other types of sigmoid distribution, and there are other bunch of distributions. But obviously if you have not heard about those distribution in the paper, and if it comes, just simply see that there will be some PDF obviously, and obviously each PDF follow first property is that minus infinity to infinity fx dx is equal to 1, and there will be some properties of that particular distribution. Obviously in the CMI paper, obviously some of the properties are given. It's not like if there's some new distribution is being introduced, then it will be just it will be out of nowhere and you don't know about it. Everything will be given there, but obviously you need to utilize those property to solve the questions, and we will actually see now a questions from the gamma and beta distribution and how we can solve it. Okay, so like beta integral, just I wanted to introduce. So beta integral, like this beta a comma b, it is represented as gamma a, gamma b upon gamma a plus b. Okay, so this is the definition of beta integral. But this particular thing is equal to 0 to 1, t to the power a minus 1, and 1 minus 2 to the power b minus 1. So, like this particular thing that you are looking at here, this particular thing, this is called a beta integral. So, if you just integrate it between 0 to 1 dx, it means simply means that okay, this is the beta mu comma mu. And what is this mu? Mu is just whatever this here, it just add plus 1, and whatever it is here with 1 minus 8, just add plus 1. Obviously, you can see the same thing here. This beta a comma b is equal to 2 to the power a minus 1. So add plus 1, that will be going here, and add plus 1 to this part, and that will be going to here. So if it's not like let's say 2 to the power, let's say something like a plus 2 and 1 minus t to the power uh, b plus 3. Okay, this is also means 0 to 1. So this is also beta integral, but the thing is that whatever is going to be here, it's equal to beta a plus, what is that, a plus 2, so it will a plus 3, and it's beta plus 3, so add plus 1, it will be beta plus b plus 4. So obviously everything of this type is the beta integral. The things that the range should be, limit should be between 0 to 1. Formula should be, there should be some t, and there should be 1 minus t, and power should be a minus 1 and b minus 1. So whatever it is, just add plus 1, it is beta a, and if you add plus 1 here, it will be beta b. So obviously it's beta plus 2, then add beta plus 1, it will be beta plus 3, and something like that, obviously. So like same thing, just you have to just consider what are the format of the original beta integral. The next thing is that you have this particular thing, this particular integral is of different type also. Like sometimes beta integral is written in this type also. So what is the difference here? The difference is that limit is changed. So limit is here is 0 to 1, but the next limit is between 0 to infinity, and obviously the format has been changed. This is 2 to the power a minus 1 upon 1 minus 2 to the power b minus 1. But here the thing is that u to the power b minus 1 and 1 plus u to the power a plus b. So this thing is also called beta ab. So this thing is also beta ab. And sometimes means if you just read about the mathematics, this thing is also written in the form of cos theta and sin theta. So this particular beta integral can have different forms, and these all forms are interchangeable. But obviously, I'm not going into the details. So these are interchangeable into one another, and you actually have to assume some transformation. So those things are not a part of syllabus. The main thing is that sometimes you'll find beta integral of this type, this is also beta integral, and this is also beta integral. Okay, so you have to do something things like that. Okay, so like on the basis of that, we have also a beta distribution of second kind. Obviously, like if you just take that particular distributions also, that we have this particular second format, and if you define based on some distribution based on that, so it will be beta distribution of second kind. Okay, so it is represented beta to mu comma b. So obviously the thing is that beta distribution can be defined into two types. The first type just in the basis of the first type of integral, and the second type is in the basis of second type of integral. First type you will have limit 0 to 1. 0 to 1, you consider here the limit is 0 to 1. And the second thing is that the second types you will have limit from 0 to infinity. So overall the thing is that gamma and beta integrals are defined on the basis of gamma and beta distributions are defined on the basis of gamma and beta integral. So those integral follow some properties. Those properties I have listed out. There are some other properties also, but that will not be useful for right now. And just you can utilize those information to solve some question. Obviously, now at this point of time, we can actually see some problem. And obviously, like I want you to specifically solve a problem from the CMI paper, because obviously I did not find any particular questions from the this particular any book or anything. So just let me solve that particular questions from the CMI paper, and it will be clear like how to apply uh, this particular question. So let me just open this particular questions for you. Okay, so where is the question? Okay, okay. So, what are those other questions that you can find from the paper related to some other distribution, some other probability? You can now solve those particular questions. So it's not like means you have to study something else. So whatever you know till now, you can solve those particular questions. And let's now just discuss some particular problem about. Beta integral, I think it should be okay. Yeah. So let's just see this particular problem. So like this what problem is there, and this is on the basis of, I think this is on the basis of the gamma or beta integral. So let's just see what is it. Okay. So 1 minute. Okay. So a proportion of visitors to an e-commerce website in a week who would purchase a product follows the beta distribution. So it's saying that there is something happening, some event, proportion of visitors, and those particular things is the beta distribution. Obviously, no, like just see the particular format of the questions, because in the semi paper, whatever the question is, if it's about some new concept, you will be given everything about that particular thing. So its probability density function is given. Okay, so this particular thing we talked about, that this is a particular this, like this particular thing can also be written in the form of beta alpha comma beta. Okay, so this particular thing can also be b, so the b is there, the symbol alpha comma beta. So obviously what is had done, it has just broken down the same thing. So I talked about the same thing in the key you have. So sometimes the beta will be written like this, and this particular thing is the uh, obviously the beta integral, the beta of the definition of the beta integral. So now the thing is that these particular things, the gamma, this particular symbol is called the gamma function, and alpha is greater than 0, beta is greater than 0, and alpha plus beta should be greater than 2. So whatever the condition is there, it has written everything. The mean and median of the beta distribution is obviously alpha upon alpha plus beta. So you can know, like we also saw that the particular mean is the alpha. Let me just show you the mean. Uh, okay, so mean is the what is the mean of this particular thing? So mean is the mu upon mu plus nu. Okay, so this particular thing is the mean, and same thing is also saying that mean is the alpha upon alpha plus beta. Now mode is the this particular thing. So like it's not like you have to remember this particular thing. Just you need to understand this particular thing. What is alpha? So obviously now know that the alpha and beta are the parameters of this particular distribution. So in order to find anything about the distribution, you need to find alpha and beta. Okay. So now the thing is that the mean and mode of the beta distribution is given. From historical data, the mean and mode of the proportion of buyers are estimated as 1 by 4 and 1 by 5. So it's given. What is the mean? So mean is now 1 by 4. So let me just so mean is 1 by 4, and the mode is 1 by 5. So mean means alpha upon alpha plus beta. This particular thing is given as 1 by 4, and alpha minus 1 upon alpha plus beta minus 2. Don't need to remember this formula. Everything is given 1 by 5. So these particular two things is given. And using these two particular thing, obviously you can calculate alpha and beta. So just 4 alpha is equal to alpha plus beta, and which it means that 3 alpha is equal to beta. Okay, and using the second equation, 5 alpha minus 5 is equal to alpha plus beta minus 2. Obviously you can do this particular thing. Then 4 alpha, then it's went to the other side, then equal to beta plus 3. And obviously you just put beta is equal to 3 alpha, then it will be alpha is equal to 3, and if alpha is equal to 3, beta is equal to 9. So this particular option is correct. Okay, so whatever the mean and mode is given, you have to solve this particular thing on the basis of what are the values given in particular question. Okay, so this thing you can do by yourself. Okay, so I am not applying any advanced concept or everything. The information that has been given, we are trying to solve the particular questions on the basis of what has been given to you. Okay, now the thing is that obviously these are the multiple correct answer, and that's why a lot of questions can be framed on the basis of the same particular information. So now the thing is that which of the following statement are correct? So first statement is correct. Now the second information is the probability that in a given week the proportion of visitors who buy the product is between 10 to 20% is given by this particular thing. So it means that x, now x follow the beta distribution. So x, now it's saying that find the probability that x will be between greater than equal to 10, okay, and less than equal to 20. Okay, so it means that you can just see that this particular thing is between that. But obviously like it's talking about the percentage, so just don't write 10 or 20. It's about 0.1, 0.2, because entire x range should be between 0 to 1. So overall this particular thing, it's want to say that this particular you need to find a probability that x should be greater than 0.1 and less than equal to 0.2. So obviously to find this probability, you have to apply the integral formula, and you have to put the integral here from 0.1 to 0.2 dx. Okay, so what is the thing is that here some things are written. So like we need to understand what this particular thing means. Okay, so let's say this particular thing is the whole range of between 0 to 1. Okay, this particular thing between 0 to 1, this is probability of the same thing, obviously the same distribution is there. from 0 to 2, 0 to 0.2. So 0 to 0.2 means, let's say something 0.2 is here and 0.1 is here. Okay, so 0 to 0.2, this probability is there, so this probability we need to find, and then we minus, we're subtracting the probability of 0 to 0.1. So 0 to 0.1, then at the end what we will get, obviously we are getting the probability of this particular thing, this the required probability of 0.1 to 0.2. So obviously this option should be correct, because this is the required thing that we are trying to find out. So obviously, like if you want to try to find out the probability between the probability between two different points, so let's say this is between 1 to 3, obviously minus infinity to 3 you find, and minus infinity to 1 you also find. Subtract the two things, you will get this required probability. So is this thing clear, like how these two options are correct? Anyone, do you have any confusion or any question? Okay, the next thing is that the next option that you should check is the mean proportion of buyers can be calculated at this particular formula. So let's just see what this particular thing is. Like mean, anything, any mean that you see in the distributions, it will be expectation of x, and expectation of x is defined by some formula. So just let's see what this particular expectation of x is. So expectation of x here will be minus infinity to infinity x into fx dx, right? And in that particular case, this particular thing will just break it down to 0 to 1, so 0 to 1 x, and this particular distribution whatever it is. So this, like this constant is there, so just don't worry about it, just see this particular thing. So it's x to the power alpha minus 1, 1 minus x to the power beta minus 1. So this would be x to the power alpha, because this particular power will be same. But you can see that this particular thing is between x to the power alpha minus 1 and 1 minus x to the power beta. It should be x to the power alpha if you are trying to find the mean, because there is one extra x. So obviously this option is not correct. This is not the mean proportion of particular buyer. So this is not correct. And the last option is the probability that in a given week, the proportion of visitors who buy the product is less than 20% is gained by this particular formula. So obviously what is this? Like it's talking about probability that if x is there, then x is less than equal to 0.2. Okay, so it's talking about probability that in a given week, the particular week proportion of visitors who buy the product is less than 20%. So 20% means x would be less than equal to 0.2. In that case, this particular probability can be transferred as 1 minus probability that x is greater than equal to 0.2. Okay, and coming to the solution of this particular thing, this will be 1 minus obviously 0.2 to 1, and whatever this gamma beta form is, this particular beta form, and it will be x to the power alpha minus 1, 1 minus x to the power beta minus 1. Okay, but you can see that this particular thing is obviously incorrect, because this x to it should be x to the power alpha minus 1, and here should be x to the power 1 minus x to the power beta minus 1. So obviously we have just a and b as the correct option, means this seems correct, but like here should be x to the power alpha minus 1. It is yeah, yeah, hello. So did you understand this two part, a, b, and c? Okay, so in the D part, I was just stating that this particular probability that we are required is probability of x less than or equal to 2, because it's saying that this is the probability that in a week the proportion of visitors who buy the product is less than 20%. So less than 20% means the x which follow this particular distribution, or x is the distribution. So x should be less than 0.2. So it means that this can be transferred into 1 minus probability of x greater than or equal to 0.2. Okay, and this particular probability is from 0.2 to 1, x to the power alpha minus 1, 1 minus x to the power beta minus 1, and this particular constant that we have. So it seems like this is the correct option, because 1 minus 0.2 to 1 is there, and everything is there. But the thing is that here you have x to the power alpha minus 1, but you have x to the power alpha. And here it should be x to the 1 minus x to the power beta minus 1, but here it is 1 minus x to the power beta. So this options is incorrect because of this particular incorrect, means this particular mistake. So obviously in this particular questions, you have just a and b as your correct option. Do you have some other questions or anything if you did not understand in this part, in the beta integral part? So did means, are you all getting the overall idea, like how means how the questions are being framed in the paper, and from the information that you have, means the overall idea, are you able to get it? Okay, so main thing is that like any distributions, like I can show you multiple questions of distribution, and if we'll find it, everything about a particular distribution is given, and utilizing those things, like we have not utilized anything apart from this particular concept. Just we know that if you want to find the probability of this thing, obviously you need to integrate and do the integral from the given range. And obviously using this concept you can solve this particular questions. Obviously it's a multiple correct question, but it can be easily solved. And obviously some other questions also you can solve the same way. So whatever the questions you get in the paper, just try to try to think that questions that you know. Obviously there will not be advanced questions and not something like that ki, if you don't know that particular formula then you can't solve the question. Something will not like that if you just see any question. So some students were telling that ki they should I should teach the basic statistics. Like I don't think there is something to teach in the basic statistics. Like mean you all are aware of. Mean is just some the average of the numbers. uh, Obviously standard deviation you are aware of. The standard deviation is the what you can say, this is just a spread of the distribution. Okay. So and then we have mode is the most common value. Then we have the median. Median is the value that divide the distribution into 50-50 value. So half of the observation should be 50% and half of the observation should be there at that point. So these things are self understood. And so I don't think there is anything to teach. So if there are five numbers given to you, let's say x is equal to some number 1 plus 3 plus 5 plus 7 plus 9, and if you want to find this particular mean, then obviously you need to divide it by 5. Sum the number divided by. So obviously what is the complexity here to teach this kind of thing. So I think means do you require extra class for the basic statistics, or are these things self understood? Let me know. Yeah, do you have something to say? Okay. So okay. Yeah, definitely. So questions like this type of thing, data interpretation questions, uh, like you should some put some effort to try to solve this particular type of questions, because obviously, I mean, it does not require some extra teaching from my side or from someone's side. It just just the information given, you have to utilize it and to solve the particular question. Okay. So till now we have discussed a lot of things in the probability, statistics, distributions, and whatever the things I've discussed. I think you have just it was to give you the basic idea about how you can solve any particular question, and just to pick any question from the probability section, any questions you will able to solve it. It's not like if you're not able to solve it, then obviously you need to think something or maybe do something. But right now I can just make you sure that once you can solve any particular questions. Okay. So this is also questions from the gamma distribution. Okay. So obviously I have solved this question for you, but obviously you can try to solve this particular question also. So same particular type of question, there's nothing different. Like mean is given, variance is given, then in particular using those particular things you need to find alpha beta, and you have to check for all the particular things. So it's nothing like that you are trying to find some extra concept or extra thing. But obviously here the gamma integral property will be used. So your task is to just go and try this particular thing, and then you'll better understand the thing. Okay. So, like this particular finding the expectation of x square, here the gamma integral property will be used. So, just let me discuss that part. I think it will give a better idea. So, like expectation of x square, it is just about integral from 0 to infinity x square. Obviously, this particular formula will be there. So, just write it here, beta to the power alpha upon gamma alpha, and then you have e to the power minus beta x, and then x to the power alpha minus 1. Okay. And obviously this is the gamma integral of two variables. Okay, means two parameters. So this thing will be there, beta to the power alpha upon gamma alpha, and this will be e to the power minus beta x, x to the power alpha plus 1, because this is a 2 to the power means 2, and this same will be added, and this will be 0 to infinity. Obviously this integral is itself a beta integral of sorry, the gamma integral of two variables. So you have to utilize the gamma variable of gamma integral of two variable properties, and then you need to break it down into the some other part. So gamma integral of two variables, so I think I don't remember the formula of gamma integral of two variable, but if you just know the formula, you can solve it. So let me just find out the formula for you, and just let me solve it for you. Just try it right now. Okay. So just wait for some minute. I'll just see the formula on the internet, and we'll solve it for you. So do you any of you remember the gamma distribution of two variables formula, like how to break this integral? No, no, no. This particular gamma means this gamma integral of two variables. Obviously, in the gamma integral one, we have just something like it. But in the gamma integral of two variable, I think it has some more form. Okay, just let me just see this particular thing. Yeah, definitely, definitely. Yeah, you are right. So it will be, I think, it will be, it's beta to the power alpha upon gamma alpha. We have this particular thing in the beginning, and it will be, like, it will be gamma of, uh, it will be gamma of alpha plus two, right? And it will be gamma of alpha plus two, and because here we have a particular thing. Yeah, just wait. Yeah. So yeah. So I was telling ki it will be this particular thing will be broken down into beta to the power alpha plus one, I think, and uh, then it will be gamma alpha plus one. I think it should be that, right? Okay. Let me just find out the formula on the internet. What is the? Yeah, obviously saw that particular thing, and like the overall idea is to just it will break, like whatever you just write here in the terms of this particular thing, it will be broken down by this particular thing, and then you just like convert it into factorial terms, convert this into factorial terms, some power will be cancelled, and some format means something like that you will get something like that. I'm not telling the exact thing, maybe the exact thing also. So that will be depend on the particular formula. So obviously you can solve this particular way using the gamma, but I will definitely just look into the thing. I just forget the formula. I just think